Next, we're going to revisit our HUD. Find in File and find cPropGeep. This will take us to where we want to be and go to the Draw HUD Elements function. Now what we want to do is a couple of things. First, we want to make the icon fade in the proper direction. We were just concerned with getting it up and running the first time, so we didn't really bother to examine exactly what was going on, and as long as the bar told us that there was a change in fuel, we didn't really care. Now we want to polish it up. So the first thing to do is make it go in the proper direction. Now, you would think you'd be able to pass in HUD PB horizontal inverse, which is a declared constant, but unfortunately it's not implemented and will cause the screen to simply draw nothing. So instead what we're going to do is, well, do it the hard way. If we take out this inversion right here and we switch the order of the icons that are drawn, we will get exactly what we want. It's the same effect as HUD horizontal inverse would have, but this is actually implemented. Our next step is going to be to make it so that the left-hand side is never faded out. Right now you'll notice there's a lot of padding to the left hand of our progress bar. Now what happens is as the fuel gets reduced, you can see that 0 fuel is actually when the empty icon fully replaces the full icon, which means empty is well below what actually appears as empty in the HUD, and we need to fix that. And what we can do is clamp the minimum value. We don't want to just clamp it, we want to change the entire range, and we can do that using a bit of arithmetic. We'll create a new floating point value called adjusted fuel. What we'll do is we'll set it to mfl fuel plus our constant. With a little testing, you'll find that 0.06 is a pretty good value. And we'll divide by our new maximum. This ensures that the maximum value for this expression is still 1.0. Now, this is kind of a hack, and we should probably label it as such. Using the source conventions, we'll type this. Now that we have this value, it's simply a matter of plugging it into our function. Now, our final step is to change the color whenever we have low fuel. The first step of this is to decide what it means to have low fuel. In this case, we're going to say that if you have an amount of fuel below a certain constant, then we will warn you. And this means we have to define a constant, so we'll define one right up here. You could do this as a console variable, but this isn't really going to be changing much, and it's not heavily influencing the gameplay at all. We'll call it jet fuel warning, and we'll set it to 0.2. Now back down here, we'll test against that variable. Create an if. We'll say if mfl fuel is greater than jet fuel warning, then we'll behave normally. But otherwise, we're going to have a funny color. Now, we're going to need a color variable to keep track of the results from these conditionals. We'll create our color variable up here, gauge color, and if we have have normal, then we're simply going to set it to GHUD mColor normal. Cut that out, put it in here. And down here, we'll set it to GHUD mColor caution. Now this changes the colors, but it doesn't give us the nice alpha transparency that we want. Now, we can stick exactly with the values used in the quick info HUD that a lot of this code is derived from, but the quick info HUD is a little bit light, so we're going to be using slightly different values. Now, to change the blending values, we simply go gauge color. We access the fourth element, which is at index 3. Remember that arrays are index 0 to their size. And we'll set it equal to whatever we want the color to be. In this case, we'll say 150. Now, we want a little something different for our warning. We want this to flash. Now, what we will take from the old quick info is this nice trick of using a sine function and plugging in the current time. You can do this with gp globals cur_time. We can multiply it by some scaling value to change the frequency of our flash. The frequency for the HUD is pretty good, so we'll stick with that. Now, the other thing that we want to do is we want to use fabs, or floating point absolute value, to be sure that this goes from 0 to 1 and not -1 to 1. This will create some nice smooth oscillation. We'll gauge color 3 is equal to this. And since gauge color 3 is an integer, we'll have to cast it. Finally, remember, in fact, we should put the scaling inside of the fabs, or at least a parentheses, just to be sure we're not casting the float before we multiply. That would create some pretty serious errors. So, with that, we will insert our new gauge color. Fix a typo, save it, and build it. And we'll see how it looks. Notice how the GUI is a lot easier on the eyes. The icon looks nice. Let's see how our warning looks. It's a nice, pleasant flash, very clear, and the fuel stops just when it's expected to. Let's quit out.